page 738, lesson 12.3 is on measures of central tendency and dispersion. So we've talked about before, measures of central tendency are mean, median, and mode. So the 3 M's. When we talk about these things, they kind of give us an idea of where the center of the numbers might be. One thing that can affect this is if we have an outlier. An outlier is a number that's a lot greater or a lot smaller than the other values. So if you have just one number that's a lot bigger or a lot smaller than everything else, that's called an outlier. You potentially could have more than one outlier, I guess, but a lot of times it'll tend to be just one number. Just to review how we find these measures of central tendency, the mean is sometimes called the average. And to find the mean, we're going to add all the numbers together and then divide by how many numbers there are. So add all the numbers together, and then let's say you have 10 numbers, you divide by 10, and that's your mean. The median, it's the middle value or the average of two middle values when the values are arranged in order. So first thing would be put the numbers in order, say from least to greatest, and then you can find what's the middle number, or if you have two middle numbers, you'll just average those out. A way to help you remember median is sometimes roads have a median. So maybe we have these little concrete islands like we got on Franklin Street or something. Okay, those are called medians. Or like Lloyd Expressway's got just a consistent concrete wall. That's a median. And that can help you remember that because the median is in the middle of the road. The median is the middle of our numbers, okay? You got to make sure you put them in order first, though. And then the mode is something that occurs the most times. So if something happens more than anything else, it's the mode. Mode happens the most. If all the numbers happen the same amount as each other, then we could have no mode. We could have one mode, or we could have more than one mode. So, for example, for mode, if we have 1, 2, 3, we would have no mode. Those all happen the same as each other. If we have 1, 1, 2, 3, 1 would be our mode because 1 happens more often. If we have 1, 1, 2, 2, 3, 3, once again we'd have no mode because they all happen the same. We can't just say if something happens more than once, it's the mode. We could even have this. If we add a 3 on, now 3's the mode, okay? Or we add another 1 on, now 1 and 3 are the modes, okay? If they happen more often than something else, if there's something that happens less often than them, and they happen the most often, then that's where they are called the mode. So mode's a little different because it's possible we don't have a mode. We might have one, we might have more than one. Mean, you're just averaging it out. You'll have one mean. Median, even if you have two middle numbers, you're going to average those and get one median. So you always have one mean, you always have one median. Mode's a little bit different. You could have no mode, one mode, or more than one mode. And then over to the side, it tells us when we might be interested in using these. So mean might be a good measure of central tendency to use if there's no outliers. If all the numbers are pretty close together, the mean is going to be a good number to kind of tell us a description of the numbers we've got. The median might be good if we do have an outlier, because the median, we're not averaging all the numbers out. Potentially we're just averaging those two middle numbers. The median's not going to be affected as much by that outlier. And then mode isn't going to get used as often, but if we have a non-numeric data, or if we're choosing the most popular item. So like if I said, what's your favorite color? We could find the mode, like who picked whatever as their favorite color the most, more often than anything else. We're not going to have a mean for what's your favorite color. We're not going to have a median for what's your favorite color. So that would be a case where we might be interested in looking at the mode. So if we look at problem 1, they want us to find the mean, median, and mode of the Bowling scores, and then which measure of central tendency best describes the scores. So for the mean, they averaged all these numbers together. So they added them all, divided by 8, and they got 122. So 122 is the mean. The median, they put all the numbers in order. There happened to be 2 middle numbers because we had 8 numbers here altogether. So 2 middle numbers are 109 and 113. They averaged those out, so add, divide by 2, and they got 111. So 111 is the median. That's the nice thing about doing the mean first, because if you do the mean first, you can see how many numbers you have. Whatever you're dividing by, that's how many numbers. So we had 8 numbers here. That tells me, since that's even, that tells me I'm going to have 2 middle numbers when I'm doing the median, okay? And then the mode, you can see we had 3 scores of 104. That happened more often than anything else, so the mode would be 104. If you look at the numbers, here was our list of numbers that we had. And what we can do is kind of look about whether we had outliers or not. Notice the 189, that's a lot bigger than the other numbers, so that is an outlier. So the mean isn't going to be that good of a number for us to use to measure like where the center of these numbers are. Because if you'll notice, the mean was 122. Mean of 122, they actually only twice got more than 122. 6 times they got less than 122. So that's a little deceiving to say that their mean was 122. I mean, the mean is 122, but it doesn't really give us an idea of where the center of these numbers are. The median is 111. That seems more realistic with where most of these numbers are. The mode is 104. That's the lowest score they ever got. I mean, yeah, they got it 3 times, but the mode is 104. Since it's the lowest number, that would not be the best one to describe it. So that's why they said here that the median would best describe the data. If we look at the got it 1, it says consider the scores from problem 1 that do not include the outlier. What are the mean, median, and mode of these scores? So if we took out the outlier, if we took out the 189, it would end up being the mean would be 112.4. The median would be 109. And the mode would be still 104. So at that point, you could go either way. Without an outlier, if you said, I want to use the mean, that's fine. The median's technically pretty close by too, so you could probably use either of those. But I guess with what the book's saying, since there wouldn't be an outlier at that point, the mean would probably be a good measure of central tendency to describe that data. Look at problem 2. They're talking about finding a data value, so finding something in order to get a certain average. So in problem 2, it says we have these 3 grades on our exams. What grade do you need on the next exam to have an average of 90 for the 4 exams? So what they're doing in the book is they're saying, okay, we're going to be adding 4 numbers. We're going to divide by 4, and we want it to equal 90. What's different is we have an x here. So with an x, you know, we can't just add all those numbers together and divide by 4. That's not going to work. We're actually solving for x is what we're going to do. So what they did in the book, they went ahead and added the 80, the 93, and the 91 together. They got 264. And then they multiplied. They didn't really show doing this, but here they multiplied by 4 on both sides to get rid of that fraction. So 264 plus x equals 360. And then the next thing would be they subtracted 264 on both sides. And then they got x equals 96. So 96 would be what we need to get that average of 90. Okay, so that's fine. There's nothing wrong with what they're doing here, and this might be easier for you to remember than the way I'm going to show you in a minute, long term. But for right now, I will show you a different method you can use if you want to. So another method to try to work this out is we can look at what we have. So these are the scores we've gotten so far: 80, 93, and 91. So we've got 264 points so far. We're wanting to get an average of 90. So if you think about that, if you got a 90 on every single test, what would your average be? Right, so your average would be 90. So what we're going to do is we're going to say what we need. Well, if we got all 4 90s, our average would be 90, wouldn't it? So if we had 4 90s, that would be 360 points total for 4 tests. That's what we need to have an average of 90. So if we need 360, if we've got 264, if you subtract those, you get 96. And if you'll notice, that's the same answer they got in your book. Okay? So again, nothing wrong with what they're doing in the book, just showing you a different option if you want to consider doing this problem differently. We look at the Got It 2 Part A. So they told us again what our grades were, and then they're saying what would you need to have an average of 88 on the 4 exams. So depending which way you did this, if you looked at how many you have and how many you need, these are the same numbers we had in example 2 or in problem 2. So 264 is what we have if we're doing it this way. Then we could look at how much we need. So if we had an 88 on all 4, on each test, if we had an 88, that'd be an average of 88. So that's 352. So if you take 352 minus 264, then if you subtract those, you would get 88. So we need presumably 88% on the next test to have an average of 88. So our average going into that was 88 then, is what that tells me. And again, the other thing you could do is, like they did in the book, it's basically just the same process that they did in the book. So we had 264 if you add those together. And really you're doing the same stuff, really. It's just a different way of looking at it. Multiply by 4 and then subtract 264 and you'll get the same thing. Okay? And then part B, it says if 100 is the highest possible score on the 4th exam, is it possible to raise your average to 92? So we had 264. If we're going to try to get a 92 average for 4 tests, 92 times 4 would be 368. So that would be 104. It says if 100 is the highest possible score, is it possible to raise it to a 92? And the answer would be no. Okay, we'd have to get actually 104% is not possible in this scenario. The next thing we're going to talk about in this lesson is the measure of dispersion. It's how dispersed or how spread out the values are. And one thing we'll use a lot of times for figuring that out is the range. So range, it's the difference between the highest and the lowest numbers. So if that's all we're doing is the range, you don't technically have to put the numbers in order, but just make sure you're carefully looking for the highest and lowest numbers, and then subtract those, and the range is 22. If you were finding the mean was 32, and that's what it did say. What are the range and the mean? So mean we've already talked about, so I'm not going to focus on that part too much, but that's how you would do that. For stock B, the range is 8 and the mean was 32. Well, if you look at those, comparing these stocks, the mean was 32 for both of them, but stock A had a range of 22 and stock B only had a range of 8. So what that tells us is stock B was more consistent. The price for stock B didn't fluctuate as much, so that might be a good thing. We may not want the stock prices to be changing so much, so if I was looking at that the information there, I would maybe be more interested in investing into stock B because it doesn't fluctuate quite so much. So if you look at the got it 3, they are wanting us to look at a couple of other stocks. So we have stock C and stock D. They're asking for the range and the mean. Since we're not doing the median, we don't necessarily have to put these numbers in order, although since we're finding the range, we need to take the highest minus the lowest, so I'm just going to go ahead and put them in order anyway. That'll make it easier to look at the range part. So this is for stock C. Stock C, we're going to find the range and the mean. So the range would be 7 minus 1, which is 6. And the mean, we're just going to add these numbers together. And there's 5 numbers, so we'll divide by 5. So 21 divided by 5 would be 4 1/5, or 4.2. And then stock D, so almost missed the 5 there. The range, we would do 24 minus 2. So 22 would be the range for stock D. And then the mean, have 56 divided by 5, which would be 11 1/5, or 11.2. So comparing these two stocks, we can see that stock D has a lot higher of a mean. It also has a lot higher of a range as well. Problem 4, they want us to find measures of central tendency and the range. So on problem 4, they have a line plot for how many televisions are in students' households. So for this line plot, basically each X that's above a number, that represents people that had that many televisions. So 2 people had 1 TV, 4 people had 2 TVs, and so on. So if we look at that, we can find the mean. For finding the mean, you could just do 1 plus 1 plus 2 plus 2 plus 2 plus 2, and so on. What the book's doing here, they're shortcutting it a little bit. They're saying we had 2 1s, we had 4 2s, we had 6 3s, we had 4 4s, and we had 2 5s. It just makes it where we don't have to write out quite as much stuff or type in quite as much stuff. That ends up being 54. And then 18, that was how many X's we had. If you count up all the X's, there were 18 of them altogether. So they divide by 18 and they got 3. So the mean was 3. The median, you do have to write them all out. There's no real shortcut there, other than, I guess, if you notice there's 18 numbers. That would be what, the 9th and 10th numbers. That would be your 2 middle ones. So you could otherwise come over here. We're looking for the 9th and 10th numbers. So 1, 2, 3, 4, 5, 6, 7, 8. 9th and 10th numbers are both 3s. So if you average out 3 and 3, you get 3. And that's what the book did there. So the mean was 3, the median was 3, the range, we had 5 was the biggest number, 1 was the smallest, so 5 minus 1, the range is 4. And then part B, how can you tell from the graph that the mean and median are equal? So here's a little trivia for you. When the graph is symmetric, the mean and median will be equal. So if you look at this, this is exactly symmetric. If it's exactly symmetric, the mean and median will be the same. Okay? Look at the guide at 4. We are looking at how many students are in each homeroom at Jefferson High School. So they want us to find the mean, median, and range. And then we're going to determine whether the mean and median are equal based off the line plot. Maybe we'll just mention part B first. So looking at our graph, the graph is not symmetric at all. It is very skewed towards the left here. And so we could say, since it's not symmetric, they are not equal. Okay, so that maybe is a good thing going into it. That way, if we work it out and we get that they are the same, then we know that that's not correct. So if we look at the mean, again, we can shortcut this if you want. The last one's just 24. If you want to put 24 times 1, you can. A reason for putting that would be that then, if you're doing this consistently, you can look at how many numbers you have all together. If you want to just go back and count up all the X's, that's fine also. So either way, there would be 20 numbers altogether. So we're going to end up taking our total and dividing by 20. When you do these problems, I'd like you to show what you're doing first of all, and then show me what your total is and what you're dividing by. Okay? So the total for this problem should be 416, and then we're going to divide that by 20. So that would equal 20.8, 20 and 8/10. One thing about the mean we haven't talked about, the mean, it's an average. It's got to be somewhere between the lowest number and the highest number. So if I'm working this problem out and I get an average of 27, That doesn't make sense. We never even got any numbers that were that high. So 27 can't work. Likewise, if you got like 10, that would be too low. So just something to consider when you work through these. So that would be our mean. For the median, like I said, if you want to, instead of listing all these out, we know we have 20 numbers altogether. So if you can think about, we're going to have two middle numbers, which would be the 10th and the 11th numbers. So whichever side you want to start on, just find the 10th and the 11th numbers should be your median when we average those out. So whichever side we start with, we're going to find the 10th and the 11th numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 10th and 11th numbers would both be 21s. You might ask when I'm doing this, whether you should start at the top of the line or the bottom on each row or each set of X's. It doesn't matter. It's going to come out the same either way. So for the median, you could say we're averaging out 21 and 21. We know it's going to be 21, so that's fine. Okay. So the median's 21. We don't really have too much of an outlier here, so you might go with the mean if you were choosing one of these to describe the data. And then the next thing we're going to talk about the range. So then for the range, we're just taking the highest number minus the lowest number. So 24 minus 19, the range is 5, which isn't a super high number. These are a little bit smaller numbers, but not too bad for our range on that one. These numbers were pretty consistent. And then we already talked about part B, that these were not symmetric, so the mean and median, we knew going into it, were not going to be equal. Problem 5, results from the same quiz given to two different classes are shown in the line plots. And the question is, which class has a higher standard for being in the top half of the quiz scores? So what we're doing is we're going to find the median for both of these. So for Class A, they didn't really go through the whole process here, but there's 26 numbers. So 26, if you put 13 on both sides, but then that'd be all our numbers, right? So 26, we need 12 and 12, and then two middle numbers. So that would be the 13th and 14th numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So we've got 1, 3, and 1, 4. They averaged those out. So median there was 3.5. For Class B, there's 21. So it would be the 11th number. 10 on each side gives us the 11th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11th number, which is a 5. Okay, so out of that then, the median for Class B is 5. So Class B would have a higher standard for being in the top half. Because what that means is in Class A, half the scores were above 3.5. In Class B, half the scores were above a 5. Okay? And then part B, by comparing the line plots, how can you tell which mean is greater? So Class B, you can see the numbers are skewed towards the right, which means we had more people that got higher quiz scores. So that would be how we could tell. For Class A, if you'll notice, those are actually symmetric. So they're symmetric means our mean and median are going to be the same. So this would have a mean actually of 3.5. Class B, the mean is going to be higher than 3.5, as you might imagine. So if we look at the got it 5, results from a third class are shown here, and they're asking whether the mean for class C is greater than or less than the mean for class A. So comparing to class A, what we can kind of do is just look at these. Again, class A was symmetric, class C is skewed. So class C, since it's skewed over towards the left here, towards the lower numbers, that would be less than. And then part B is the median for class C greater than or less than the median for class A. Same idea, so that would be less than as well. And then part C, how can you tell which data set has a greater mean by comparing the graphs? Basically, we're just looking that we could say the data for class C are shifted to the left. Okay, I'm not going to write it all out, but then, so that means that class C would have a lower mean, or conversely, you could say class A is shifted further to the right, so it would have the greater mean. We'll look at the lesson check number 3 just to get practice with one more of these. So, a student has gotten these grades, needs to have an average of 90. So we've got one more test apparently. What does he need to get on his last test? So again, however you want to do this, I'm going to look at how much he has and how much he needs. So if we add these up, 356 is what he has. They want an average of 90. There's been 4 tests, so one more would be 5 tests. So if we had 5 90s, that would be an average of 90. So that would be 450 is what he needs. So 450 minus 356 would be 94. So he would need to get at least a 94 in order to get at least an average of 90. So this gives you an idea of how to work with measures of central tendency and dispersion. Have a good day.